In our earlier lessons, we saw the basic concept of mold design and its different prepared principles, terminology, and the way in which you do your approach. And other than that, different verticals and different domains which you can include within your mold design process, that also we discussed. In this session, we are going to discuss about the NX mold design principles, in which we look into the extract the 3D model. That means how you can prepare your 3D model for doing the mold design, how to do the checkup for your setup, how to analyze parting readiness, and finally we'll look into the initialization process for mold design. That means how to configure your shrinkage, your unit system, and so on. That will look during our live demonstration. So for understanding this, we'll take one project in which we'll understand every aspect of mold design, starting from your parting line, starting from your extraction procedure, patch, mold base, how to locate your gate, risers, runners, and standard component, how to align to your mold base, and how to configure all peripheral component of your mold design, that we'll look into. So by using this particular project in a multi cavity, so two component will see which are flipped. You can see here by using the principles for spruing it and how to allocate the risers, runners, and complete mold base, that will understand. So initially what we'll do is the basic understanding of the process is very crucial, and also I will demonstrate about the complete hierarchy of your mold design, that you need to understand very clearly, how to understand the folder structure and the navigation bar structures, that also I'll look into. So before moving ahead, if you are having your DVDs or USB dongle, there you will get a card holder zip. That zip you have to extract, and within that you will get the card holder file, and then you can start NX. And after starting NX, you can choose file, open, and you can get this particular part. That part name is call holder underscore validate. Because we have used a suffix validate, because you have to check all the peripheral concept of draft analysis before moving ahead. So you have to also allocate your core region and cavity region out of your model, and then you can move ahead for future configuration. So how to start and align, that will look into. Now we can see that if you have the mold wizard library installed in your system, you can directly see all the MW library, mold wizard library installed in your library panel. And if it is not working, you can contact your system administrator, so he can sort out this, and then you can reuse it, the standard part, inside your NX mold. So I will show it, so how these are working. If you go to this particular tab, this is your reuse library. Once you go to reuse library, here you can see the UDF library, the user defined library, and below that you can see the MW, the mold wizard dedicated libraries. So you have library for the slide and lifter libraries. Here you can move inside, and you can see for the slider. These are for the slider. Once you select it, you can see the preview. Just like that, you have lifters. You can see the preview here. Also, you have standard parts like the angle pin and springs. Also, you have the standard part libraries of the different standard, Futaba, Haskell, and Misumi, etc. So once you go to a particular standard, there you can see the locating ring, injections, ejections, ejector miscellaneous, and screws, dowels, guides, locks, all you can see and you can reuse inside your project. And cooling fitting also you have. You can see the cooling fittings and different standards are available which you can configure. Just like that, you can have the insert libraries, the cavity and core inserts, workpiece you have, the standard workpiece, and you have the cooling standards as well. The baffle, connector blocks, all this you can reuse it, the cooling gates. So in this way, once you have configured this properly, then you can reuse in your project so that you can optimize your design experience. So let us look into a couple of configurations which are very vital and critical for increasing, or you can say enhancing, your visualization during the mold design work. So this mold design icon you can activate through this start all application, and here you can see mold wizard. So in this way you can activate your mold wizard and you can access the libraries and all facilities inside mold design. So let us look into a couple of configuration for increasing the visualization. So as a part of visualization, you can set the modeling for controlling the Boolean face target and tool body experience. So for this, what you have to do is it increases the contrast, or you can say a better color inside the parting section. So what you have to do is you have to do a couple of setup here. So you have to go to the preference and you have to go to the modeling. Here you have a general tab. Under this you have options, display properties for new geometry, and under that you have a Boolean face properties from. So these options by default you can find target, which you switch to tool body and go for OK. And by doing this, what happens is you have a better color contrast for parting section of this project. Just like that, under the preference assemblies, you have the emphasize for visualization experience work part. You have to emphasize, and by default it is selected. Just we have a recheck of it. Go to preference and you go to assemblies, and by default you can see the work part emphasize has to be checked, and just you check it whether it is ticked or not. Just like that, you have a color visualization preference under the visualization, and you have color and font. Under this you have a emphasization and de-emphasization schema. If you go to de-emphasize, here you have the blend colors, which you have to take white, and blend percentage you can vary from 10 to 100%. This basically plays a very critical role when you want to make your assembly work more visible. That means when you are working with the mold base and complete mold design are on the go. So choose preference visualization on the color font tab, which I have shown parting setting group, de-emphasize, and set the blend color to white, and the blend percentage you can vary from 50 to 80, and here we have taken 70. So this preference makes the assembly more visible. This is what is our target. On the resources bar and rule, also you can set the different rules for full menus control. So I will show this, and this is very fundamental to control the rules. So So what rules does is, when you go to rules, here you have couple of options. You can see the advanced with full menus, essential recommended. Essential is a cutoff where you get the options with low order. But in case of your advanced with full menus, you will get all the options inside this, and later you can configure your options as well. You can see all the options are used in case of your advanced user experience, and which you can navigate and use it. So based on your experience and expert level, you can have the rule set here, the default rules which are configured by NX. So that will be very much useful for you before moving ahead with any project. I can go to full menus, and also I can go to the advanced. In case of advanced, all the options will be configured and which you can reuse, or you can go to essentials with full menus also. Essential is a must which you have to set it. Now we'll move to the parting readiness. That means we are going to check that whether the parting line which we are going to create inside your part are ready or not, whether we are lacking anywhere for your drafting. That will fix it. Then we'll come back and address those inside your part. We'll add fillets, we'll add draft, and we'll fix the problem. Multiple validations help you to identify the design defects that I was talking about. The design defects may be found after doing the manufacturing, but before that we have to take care about all the process, because when you eject the part, when you after cooling, when you move or extract the part out of the core and cavity, your final part has to be perfect in terms of the dimension, so that you take care from the parting definitions, and by using a very important concept that is known as the draft analysis. So how to do it? You can analyze and mold part validation and check region. And as this present project is a single body, you have to take care that also. Then you have to go for the check. So I'll show you how this can be done. So once you go to the analysis, mold part validation, and you have a option known as check regions, it analyzes your plastic or casted part, and it will give you the details about the molding ability, or you can say moldability of this particular component. And by default you can see, as you have a single component, the part body 1 is selected here, and you can see the draw direction out of these 3 different axes, in which directions you are going to draw. That directions you can set the different draw directions. So by using this reference, it will show you and it will calculate you about the drafting. So once you calculate it, you can found the total number of existing phases in your project. So you can see here total time spent is 5.95. So more or less you can say 6 seconds is taking to analyze it. In case of a complex part, it may be to 10 seconds to 15 seconds. So once you go to the phases, here you can see the positive draft which is greater than 3 or 51, which are displayed with this color. So how to find all this color, and we'll look into this. I'll just go to this set color for all phases, so that it will activate and it will show you the different draft regions. So what I will do is, I will show you about the positive. If you see the positive, it will show and highlight the 51 phases. Just like that, less than 3, 47, that also it will show. It will highlight it. You can just switch this to this side, so that we have more space. I can show you clearly. Just like that, which is equal to 0, 24 phases, that also you can see all these phases where the draft are not proper, and those are 0. So whether it is going to create problem or not, that we'll look into. And negative drafts, you can see here less than 3 and greater than equal to 327 pages. That all independently you can look into these pages. So this is the color note. And now you can independently see this color and those shaded areas. Undercut areas 2, crossover faces 4 with this color, and all will be shown in this particular areas. Now we'll look into the draft angle group, and where you can find the different range from greater than 3 to less than 3 and equal to 0. The total count shows 180 faces, and in the draft analysis limit box, if you go for 1 and press enter, the result update to reflect the change in the draft angle. So if you change the draft angle limit, that also can be done. And here you can see draft angle limit is 1, and once you go for enter, and this total 180 count which you have, based on that it will show the new updated faces. So in this way you can check for a particular draft angle how your whole model is behaving, or what refinement you are planning to do based on your draft analysis. So with the draft more than or equal to the draft limit, and with less than the draft limit, and with no draft, the vertical faces and undercut faces, these are different categories which you found during your draft analysis. And if you see the vertical checkbox, these areas which I have shown are displayed, and examine the highlighted faces, and different reefs and undercuts which I have, those are categorically shown here with no draft, and you can move and select it faces, and you can improve the visibility as I told during the analysis display. And just like that you can check the undercut areas where you can find the draft specific to those areas as well. And if you see these two particular faces, this curve faces where you have fillet, because of those fillets, the theoretical curves which is joining is creating a zero draft. But typically if you want to remove it, what you can do is you can modify this and attach a fillet, and you can fix it. I will show typically this problem what I am talking about. If you zoom these particular areas, you can see this is the bottom side. Here you have a sharp corner, right? Here you have a sharp corner, whereas here you have a fillet. So the continuity can be addressed by attaching a fillet here as well. So after that, when you do the draft analysis, this will be fixed. So for understanding this, what you can do is you can go through the modification process and you can validate your part, and after that you can move ahead for your molding, and after that you are okay with all the preset which is required for your project. Now you can see the difference. If you can see the particular part where we have added in the bottom side fillet, this side, this edge blend, and here also, and after that when you do the analysis and you examine this again, you can directly go to the analyze and mold part validation, and you can go to the check region, and after that, as per the normal directions, you can perform the checks. And when you see the report, now it is 184 because the fillet surface is added, and after that you can do the again counter analysis, And you can see this particular region with this particular color is less than 3. This particular region, the positive with the yellow color, are with less than 3. So like this you can change and you can set the required draft, or the moldability experience can be attached during your design work, that can be configured to your model. So in our coming session we'll continue with this chapter and we'll look into the basic project initialization. Thank you.